Welcome everybody to this session about performance and scaling in particular. I'm Yannick Robin. I'm director for expert services in Southeast Asia. And today I have with me Jumbo Cheng, who is principal consultant in Greater China. So today there are many different angles that we can have to discuss about performance. This session today is really dedicated to architect and developer. So Jumbo and myself, we thought that it would be a good idea to put a lot of technical input in this session. So different angle. The first angle will be more oriented on the code. What are the most common mistakes in the code that we see that are impacting the performance and prevent the system to scale? Caching is very important for scaling, so we'll have a dedicated section for this as well. Jumbo will present the cloudification, so all the improvement that we had in the recent releases of Hybris Commerce to help for the scaling, and a specific topic dedicated to the auto scaling. And then, depending on how much time we have and how much time we want to let for questions, I will go through some specific design to get a creative architecture to scale. So let me start by the first one. Okay, the most common issues that we have seen in the code. We are used to do in expert services code reviews or performance investigation. So I think that we have a quite long database of issues that we have found in the code, and in this section I try to list like the top N code mistakes that we have identified. For each of them, I will explain what is the issue, what is the symptom, and what is the typical correction that we can see for the problem. Let me first start by the converters and populator. You probably already know that the populators have a lot of work to do, I would say, in particular the one for product populators. And they are very CPU and sometimes also the resources like database intensive. So it is quite common to see high CPU usage on the application server, and because they create a lot of short-term objects, short-lived objects, you can see also excessive garbage collection with populators, in particular the custom one. So a typical way to understand the problem is to we have specific techniques based on thread dumps, for example, to be able to classify the top end populators that are impacting the performance. So it's very important that you understand by the analysis of the thread dumps or use of an APM, what are the populators that are impacting the performance. You can be focused on this one to optimize them through review of the design of the populator, review of the code, and change of it. A typical mistake is incorrect usage of product options. So in the converter for product options, give a choice of the populator that should be executed for a specific call. So depending of where you are in the website, for example, maybe on the product detail page, you want to execute all populators, but on the product list page, where you maybe display 50 different products on the same page, it's very important to be careful here to not execute all populators. So to just mention the options that are necessary for a specific page or a specific action. Last but not least, I will go back to this topic a little bit later when we will speak about caching, but caching of DTO, so basically the object that is generated by the populators, converters, and that you want to expose to your customers. The caching of these DTOs provide massive performance improvement. Another typical issue, which is actually not specific to Hybris, but for any application where we use a relationship database, we can see sometimes that the database is overused with the high CPU and a lot of I/O on the database. On the application server, a lot of threads waiting for the queries to be returned. When you see this, our recommendation is to activate the JDBC logging that is available through the HAC. So this way you can isolate not only the slowest queries, but the top end queries. So the one that are impacting the most performance. So usually it's a combination of the number of the execution and the average response time of the query itself. So with the JDBC logging, you will know which query to focus on. Then when you have identified the queries that can be that are the one that are impacting the most performance, you have the typical methodology to optimize queries. I will not go into details, but obviously to generate an explain plan is a way to go, and then there is different optimization mechanism depending on the query itself. We mentioned here indexes or replacing in by joins, but I mean you can have many optimization. It's really case by case. Maybe something specific to Hybris that you need to understand is the way the ORM cache is working. And in the query, if you have like some elements of the query that are very fine grained. So a good example that we usually take is a date. So let's say a date that gives you the milliseconds, for example. I mean, there is very small change that the caching is efficient. So again, here an optimization is to say, okay, reduce the precision of the date to optimize the caching. So for example, maybe the day is enough, or the hour is enough, or the minute is enough for the argument that you expect in your query. Another typical issue is related to invalidation of the cache. So again, here we speak about the cache for the flexible search queries. So the cache in the Hybris ORM. When you have, for example, a cron job doing a synchronization or importing indexes, importing catalogs, this kind of stuff, you can have a lot of writes on the back office. Okay, all these writes will create invalidation messages, and at the end, in particular, if it's in the middle of the day, it will obviously all these invalidation messages will make that the cache will be very inefficient, and it's why you will see a high miss rate ratio on the region cache. To optimize this, obviously, I mean, a typical recommendation, that is the case for synchronization in particular, but not only import of products, this kind of things. It is recommended to avoid running this in the middle of the day and more to run it during the night. It is not often that I see cases where we really need to do publication at any time of the day, synchronization at any time of the day. This is obviously a kind of business rules that you can introduce with the business user team. So that is one way. Another way is to have a clear separation of the back office and the front office. If they are in two different clusters, Hybris clusters, it means the invalidation messages will be only for the back office, but will not impact the front office. So when you can segregate the two clusters, that makes it easier. Another one is something that you can introduce in the code when you do the query. So here it will be more on the front end. Let's say, for example, the stock is modified very often, and you see a very high invalidation rate and miss rate on the stock row. A way to optimize this is before doing the query, encapsulate the query with some argument in the code in order to have a TTL associated to the cache in the query, so in the ORM. So this way, even if the server receive invalidation message, maybe your value of stock will be valid for like 2 hours, 2 minutes or something like this. So TTL is also a good way to improve the performance for this. Another typical issue is related to calls to external systems. So call to a web service, for example, synchronous call. Here you will see the number of waiting threads waiting for IO response from the web service, right? You will see it increasing. So if you do a thread dump analysis, if you see a lot of calls like this, this is where you need to optimize the call that you do to the external system. So an obvious way is obviously the system itself, right? To understand where the latency comes. So maybe the system itself is slow, so maybe the fix needs to happen on the system itself. Or maybe what you are using as a synchronous call right now, maybe you can do replace by a call asynchronous. Also, typical ways to cache the results. So multiple users will benefit from this cache, and you will not have to call the same web service again and again for the same information. That's obviously optimize a lot of the performance. The last one that I wanted to put here is more a kind of protection mechanism. So based on histories, I will give more details later in this presentation. But basically, with this library, you cannot optimize the performance of the call itself, but you can execute these calls in a pool of threads, or you have more control on the monitoring as well, more control on the system failing, and this way you can avoid, in particular, to saturate the external system. Let me move to another typical issue. I give an example here in the code related to our ORM. So with the ORM that we provide, when you have a relationship between two objects, we obviously propose some getters to get the items, the objects in the relation. So it is an example here of getter when we do get all content pages, right? And it is quite common to see, I would say differently. I would say that this kind of getter to get the object from a relation is not the good way to do when you have a lot of items with a relation. Because then you will go through a loops of all these items. And here, for example, is try to filtering the content page that is the home page. And if there is like 1,000 content pages, it will have 1,000 iterations, and that will be very bad for the performance. Obviously, the right way to go with this is sometimes to not use naively, I will say, the ORM, but to do a direct query. So sometimes the ORM is not adapted, right, for all logic. So sometimes it's just better to do a single query where the filtering could be put in the where clause rather than to put this on the Hybris cloud later. Okay, let me move to another aspect, which is related to the cart. So we see sometimes on some customization done on the accelerator that for every single person browsing the website, a cart is created. Whereas usually you have like 80% of the audience, 80% of the sessions that are just browsing and that will not add any product to the cart. So it is very important to create cart and load the cart to the session, which can be very CPU and database intensive. It is very important to do it only when it's necessary. So only when you add product to the cart. And this, the API of Hybris provide a mechanism for this. So the cart service has a method called session cart that you should check before calling cart service.getCart, get session cart. Sorry. If you use directly the facade, this facade already have this check mechanism. But sometimes what we found in custom code is like the service is directly used and without doing the check first. So that's something where you need to be careful. The last advice, we have a long list, but for this webinar, this one will be the last one. You will be surprised how much the loading with Log4j can be. We can see sometimes how much can be performance impacting. So when your application is producing a lot of logs, you can have a lot of threads waiting on the Log4j category appender. And this is usually because of the wrong level of log, or because in your custom code you put some logs at the level info, at the level 1 or error, whereas it should be just info. So for this, it's very easy. If you see a lot of logging and if you see contention on this specific thread, log4j category appender, the good approach is to review the logs that are produced by the application and to try to understand what is producing so much logs and to fix the log level associated to this code. So that was for the most common issues. And now I will move to another topic, the caching. As I was saying in the introduction of this webinar, caching is really key in terms of strategy to achieve high level scalability. And actually, caching is important as each of the different layers of the architecture. So as you already know, Hybris has a typical 3 layers architecture: the web server, the application server, the database. And higher you cache in the hierarchy, better is it for the performance. So everything you can cache at the web server layer, better performance you will have. If you cannot, you should cache on Hybris, and what will be done on the database will see a big impact. So let me list actually the typical performance caching mechanism that we have at each of the different layers of the Hybris architecture. So if we speak about the HTML part or the static content, here the caching mechanism that we have in Hybris is more related to fragment cache. I will give more details here. After this, the DTO, so basically the data that you want to expose to your customer, coarse-grained data. We can also propose DTO caching for this. In Hybris, we have the ORM, so with the flexible search, there is some region cache associated to it. And at the database level, there is also each of the database as the JDBC driver doing some caching, and you have caching on the database side as well. And if we want to continue further, you have also at the CPU level some caching. So anyway, my message here is that you need to ensure that at each of the different levels, you have tuned or put the mechanism in place correct to do the caching. One level is not enough. Obviously, higher you cache, better it is, as I was saying before. But in the meantime, it will be very coarse-grained objects, right? So there is big chance that if you cache higher, you can cache only a small piece of information, uh, because the other piece will have to be invalidated quickly, or it will impact the personalization that you can put on your website. So it's not possible always to cache everything at the web server layer, for example. So you should cache as high as possible, but in the meantime, there is a trade-off between caching and time to live of the object that you want to put there. If we speak about caching of the static resources, you have to ensure that you put the right meta information in your HTML to be sure that the browser will cache all the information. You have, of course, to ensure that all the static resources are served directly by the web server and not by Tomcat, not by Hybris. And the last aspect is that I wanted to mention here is the use of CDN. Obviously, CDN is very good to do caching for static resources, for media, and the way to cache is that it can be very close to your customers. So obviously, it can help to scale, but it also can help to reduce latency. In particular, if you have a worldwide website. Another caching that is not known so much is again provided by CDN, internal CDN like Varnish or famous CDN like Akamai. It is called the ESI technology. So caching on the server side. You can define blocks that in the HTML that the CDN will be able to interpret, and it will be able to cache and to give a TTL associated to it. So that's probably the best way to achieve very big performance, is to ensure that most of the website is cached on the CDN side. Obviously, as I was saying, I mean, we try to do website as much dynamic as possible, so you cannot cache everything for forever. It's why we need other mechanism. A mechanism that is provided out of the box by Hybris is a CMS component caching, so you can easily activate it. I shared here the local the properties that you need to put in place to cache, and you can tune it. By default, the caching will be done by language, by currency, and by user group. But the personalization that you can do here is quite limited, right? So you should not use this for components that are personalized, or for components that contains information that are very specific to the browsing, very specific to the customer, or very specific to the customer, to the time you execute, you display the page. Something that is more flexible that we use quite often in expert services to fix quickly some performance issue with the JSP and with the rendering of the JSP is to use fragment of cache with tag libs. So we have created tag libs. It's very easy to do. I mean, obviously, if you have expert services in your project, you can ask, but by yourself you can do it as well. So you will do a tag lib that is based on EH cache behind the scene, and so this way you can encapsulate the specific fragment of your web page that you want to cache. And this is very flexible because you can indicate, you can control the key of the cache for this component, and on the key of the component you can variabilize as much as you want to be sure that you don't cache the same thing for all users. I already mentioned DTO caching earlier. So again, this is a package that has been created by expert services, and you can get access to it if you have expert services participating to your project. That is a package to be able to cache the DTO. So as you know, the populators, the converters transform the model into DTOs. These populators can be very CPU and memory intensive, and to cache it is a very good practice, and and we have a library for this to make it quite easy to put in place and to tune. Obviously, you can do it by yourself as well. Okay, so that was my last slide about caching, and now we are going to speak about cloudification and what is available in the newest release for cloudification. And for this, I will let Jumbo continue on this section.
Thank you, Yannick. So now I'm going to. Yes. So I was going to talk about the scaling on the cloudifications. Please go to the next slide. So by default in Hybris, we usually have like a practice to separate the front-end nodes and the back-end nodes. The reason behind it is like the demand for both nodes is quite different. On some big sales event like the Black Friday, we want the system to be capable to handle the traffic as much as possible. But at the same time, because like it's only serving on the front end traffic, so we want to suspend the activity for the like I say the con job and the order process, registration process running from the front end node, and so that like in Hybris, since the Hybris version 5.5, we actually can be able to control like on each node whether you want it to have the task engine started as we listed here. And sometimes we will have the backend node will be further divided into like processing nodes only, which means like there are some nodes serving for the storefront traffic, and sometimes they will just like serving for the backend UI. And another node group will be served for the task engine and the con job. This is quite typical for some customer that having a large set of product when the synchronization or the solar index ticks are quite high on the system capacity. So with the configurations like separations, it's easier for us to divide the nodes into different grouping. So we may have like it will be easier for us to, when we do the scaling, it will be easier for us to control whether we want to scale up for the front end servers or like the back end servers, while like after the Black Friday event, how you want to handle the order in some cases like that. But that will increase the capacity on how we manage the configurations files, and we will go through how we should handle those configurations files. So on this slide, we will talk about like how actually Hybris can facilitate the provisioning. So we have two practice. The old one is like performing on the virtual machines. In Hybris, actually, we can specify by our properties, we can specify different op files in the Linux systems. So sometimes we'll create two different system image, pre-binding those directories, the Hybris config directory properties, into two different share folder. One share folders contains the front-end node configurations, and the other folders will contain the back-end node configurations. This one is more kind of like a traditional approach onto the VM technologies. The problem is that like it will take longer time for us to start up the instance to scale up. Because once we start, starting the VM image, we may still need to make sure that we have the latest source code deployed into the image. There are several tools nowadays can facilitate the build process, like the Ansible, Puppy, Puppet. But since like this VM image is like a heavy, very big, heavy-weighted image, so it's still like a relatively more effort in order to maintain the image, keeping it up with the latest software versions. So since like Hybris 6.2, we introduced the containerizations of the Hybris. So with the Hybris, now we comes with two different recipes. Some of them we already prepared Docker image and Docker script for you to running the Hybris into the Docker approach. And we already have the Docker compose command so that you can, the Docker image will be prepared as like the Hybris Commerce Platform, Hybris Solar, Hybris HSQL or MySQL engine, the logging engine, etc., etc. And with the command, as you see on the right-hand side, we can actually bring up the Commerce Platform as a front-end node or the back-end node. So it will be easier. It will be, since like Docker is like already quite small weight and tighter into the build process usually. So every single time when we build a new release of the source code, it will be easier for us to prepare the latest image whenever we would need it for the scaling. So we can make use of the tools like Kubernetes or maybe manual command here. Also, when we do scaling, auto discovery is a very important feature that provided by Hybris. Since Hybris cluster is relying on the JGroup protocol in order to perform the cache invalidations and the discovery of the new Hybris node. So Hybris supported like the auto discovery via two different protocols. One is like through the TCP network or the TCP protocol or UDP protocol. With our experience or like what we've been seeing, sometimes like we find that like in some setup, it is quite important to specify which network interface you are using for the JGroup to broadcast the message. Because if for the incorrect settings, the broadcast message go into the different network subset or the different subnet, then the message will be lost, and then it will lose the functionality or the capability to find a new node within the cluster set. And also in some network setup, we have to specify in the Tomcat, in the JVM, that we are using IPv4 to ensure that the network is translated and our settings will be being in place properly. In some cases, we find that like the network protocol, the broadcast message is not very reliable. So in Hybris, like with our pre-configured JGroup TCP.xml, we will have some cases we will need to use the JDBC ping in order to avoid the network issues or the network latency for discovering a new node. Next, please. And also, while like since if we can scale up, scaling down is issues. Usually, by in common practice, we will have the load balancer have a sticky sessions. So that means like whenever the consumer traffic comes again with the same session ID, we'll route them into the specific nodes. But since the traffic goes down and we want to scale down the instance, we don't want the customers to experience like session loss that they have to log in again in order to continue their shopping journey. So in this at this moment, then centralized session failover is quite important. With Hybris, since Hybris 6.3, we implemented this Spring sessions, so the sessions will be able to persist into the JDBC and share by all different cluster nodes. so that when we shut down one Hybris node, the session will still be accessible by another node through the JDBC. But since JDBC may be too heavy for storing the sessions, for per surface perspective, we'll recommend to move that into the NoSQL DB. And finally, not the last but not the least, is the Solar Cloud support. Solar is kind of quite lightweight, and we can also distribute the traffic by the original Solar replication or with the POPC to diverse the traffic. But with the Solar 6.2, we have enhanced the Solar Cloud implementation. We have enhanced it to work with the Solar Cloud. The best part for Solar Cloud is that the configuration management is being handled by the Soonkeeper. So the replications of the Solar configuration files will be more complete. Let's say those like stop words, synonyms, and dictionaries. Whenever you export it or modify it on the master node, it will be replicated to the client node. And Hybris already pre-built the package with the Solar Cloud. So with the end command here, you can start up a Solar Cloud instance with the Soonkeeper as a host, and also you can specify the Soonkeeper host name, and then start up the Solar slave. Next, please. So in the end, so once we have done all those configurations and preparation works, we can get into the auto scaling. Why do we want to do auto scaling? That's actually from a cost perspective. With a fixed capacity, we always have different issues. It's we have a wasting, we have poor service while the loading is higher than our capacity. We have waste of money while our traffic is lower than our capacity. So we want, ideally, we want to have a best fit that our system capacity will go along with the load. So on AWS, we will use AWS example. In AWS now, they have a product called auto scaling. The service is actually relying on a few different components. First is the CloudWatch. The CloudWatch will be able to help us to monitor the system capacity. Either you can define by the system node or by the CPU loading. And it can separate into two different scaling groups, the rack tier or the application tier. The scaling group, the CloudWatch will monitoring on the scaling group to see the system capacity. Whenever the capacity is getting too high, then it will create a new instance. And the ELB, elastic load balancer, will help us to balance out the traffic, distribute the traffic onto the new nodes. But why auto scaling is very difficult, because when we do the provisioning, sometimes we will the loading is actually come faster than we be able to bring up the instance. And when the traffic goes down, it still have a latency for us to bring down the system capacity down. And also there is a safety factor in it, because when the traffic gets too low, we still want to maintain a certain level of system SLA. So when we do a statistic provisioning, it's not dynamic enough for us to catch up the traffic. And that's why we will introduce auto scaling provisioning methodologies here. On our solutions we proposed before, we actually here is debating, do we still need a web server on a cloud environment? Since for the web servers on the traditional or typical approach of the hybrid system deployment, the web server's purpose is to deliver the features we listed on the left-hand side. But on the cloud environment, Actually, especially on the AWS, there are functions provided by different components. Like the ELB, it will help us to do the SSL hands-off, the SSL terminations. It will help us to do the software load balancing here. And the other purpose is that whether we can provide a compressed content, we can cache out the static contents. So in here, the CDN can already achieve the purpose. So actually, on our recommendations that are showing on the next slide, we will actually suggest to eliminate the web server tiers. We will just propose to have two different scaling group. One is for the front end tier, and another one is for the back end tier. Next, please. So on the solution architecture, you can see that we will have few different approach here. Actually, we will go to the final part is that we have different approach. The final part is we will propose to having an ELB, and then combining the web server, the Vanish server, the front end server, and the Hybris back end server into different auto scaling group, and then it will directly connect it to the ELB. And then we would delegate the static page caching onto the CDN. The CDN can either be lined up with the S3 for the static content, so that it will be more straightforward for the CDN to help us to cache the static content. So what are the challenges when we do the auto scaling here? As we said before, the startup time may be an issue because if it's a VM machines, not only we have to really start up the virtual machines, and also we have to check whether the coding is latest. And also we will have the warm-up period, because if we just bring up a cold node onto the hot network, then the caching is not there yet. So if the consumer traffic or the request been routed onto that node, then that will create some dissatisfactions to that consumer. And also, we have to have the health check, because we want to be sure that the node is warm up, available for access before we want to the traffic switch onto that node. And another issue is downscaling. As we mentioned, if one node is being bring down, we want to have the session be persist so that the customer will have a seamless experience on the front end. And also the logging, because once we shut down the nodes, then the log file is not accessible anymore. So we may need to introduce maybe a share folder for the log file, the Linux command like the syslog, or other log management tools like Graylog or Spun, in order for us to able to retrieve the log and able to debug if there's some problems happening. And ultimately, the DBs may be an issue as well. Once we scale up the application server, the database will be the final funnel to handle all the sudden increase of the traffic. So we have to make sure the database pool will be able to take up the load of the sudden spike of the database connections, and so that the database pool should be able to be scaled up as well. So on AWS, there may be Aurora, or Azure, there will be Azure SQL that will be proven for a scalable database service.
I think it was your last slide, Jumbo. So thank you very much. Amazing.
Thank you.
Okay, we don't have so much time remaining, but for the last topic, the character architecture design, just a few minutes, so let me go through it very quickly for each of the architecture design that I wanted to present here. So the first one is related to using a slave database. So in Hybris we support replication, right? And whatever the database that you are using, we can put a replication mechanism for processes that, in particular, cron job, that it can be very read intensive on the database. We propose some code mechanism to be able to encapsulate the code and to indicate that it should be run on the slave data source. So just for you to know, it's something good to remember. I already mentioned Hystrix in one of the previous slides. I find this library amazing because it provides a very nice, very nice features to be able to isolate calls to resource intensive libraries or resource intensive systems. So Hystrix will provide some design patterns that are quite interesting for resilience. One of them is the circuit breaker. So the fact that if you call a system that is failing, you should have a mechanism to fall back to something else in order to continue to serve the customer. Another typical pattern is with thread pools, with semaphore, in order to have like concurrent limiter, concurrent request limiter in your application, and is providing, with the help of Turbine, some nice dashboard so you can monitor your application. Another one is the waiting room. So this is when you have, for a very short, limited period of time, in particular, for example, a campaign or something like this, massive traffic coming on your website. Jumbo spoke about the way to scale and to auto scale. So that is a mechanism, but it has limit. And it's always, I find interesting, always to have this kind of things that you can activate on demand. If you know that your website for a very short period of time is getting a lot of traffic, you want to protect your system. So it's more a workaround to be able to protect the system when the pattern that will be used will be the semaphore. So usually that will be done with a web server. This will be done with a web server. So you will monitor the number of concurrent sessions that you are on your website. And if you go over the limit, well, very simple. You just redirect to a waiting page, I would say. That's what we call the waiting room, a page that can be cached and can serve a lot of traffic. So this way you prevent your system to go down. Another one that I really like is SecureS. So all the patterns that I present here are something that we have done on projects, but that are not by default the architecture in Hybris, but that we have done in projects. So with SecureS, you will separate the read and the writes. And in particular with the populators. So I already mentioned that to generate the DPO is very intensive in terms of resources for Hybris. And if you think about it, I mean, for in Hybris by default, it will generate DPOs for every single call from the customer, whereas actually it's always the same. And when you have a very large catalog, obviously, I mean, the approach to optimize the performance of the populator is to do caching. But when you have a very large catalog, the caching will be difficult to manage. So it's where the SecureS architecture can be useful. Because we will separate the writes, so everything that is coming from the more like the back office, like the product cockpit or cron jobs, and that will modify the Hybris database, but it will also populate an event store database, and you will have event handlers that will be here to to take these event stores and to execute the populators. But the populators will be executed on the back office and only once, right? Then it will populate a data store dedicated to DTO. So usually this data store will be a NoSQL database. And this NoSQL database actually could serve the website. So think about it like your website rather than to call populator that calls the database, Hybris database, and for each or every single call execute all these queries and this transformation. You call directly a NoSQL database where everything is already ready. DTOs are already there, and they are already ready to expose to your website. What you can use for your website, you can use also for other aspects. So it's also very good to use the DTO data store to be able to export to other sources. So export to Solar, for example, but export to other systems like Google Shopping, this kind of things. So I find it very convenient, and this is useful when you have a very large catalog. That's the kind of strategy that we put in place. Okay, sorry for this. I went very quickly, but